Let me show how the axis deals with subhorizontal surfaces when we're measuring strike and dip. It's so easy to be absolutely wrong when measuring the strike of a nearly horizontal surface. In this case, you can simply set the lid of the compass directly on the surface. You've determined by looking over the surface a part of that surface that appears to be representative of the whole, the average, and then rotate downward the body of the compass, and then rotate the lid of the compass until such point that the bubble is levelable just by lifting, in this case, the body of the compass. Then press this several times so as to lock in the azimuth of the strike, and we're just about there. The strike reading is 252, and the dip reading is 4 degrees. Very gentle dip. So this subdetachment fault gives us a nice opportunity to use the axis to measure a nearly horizontal surface. So again, just fit the lid right to the surface, hold it tight, rotate it to find the strike line by getting the bullseye bubble in a position that it can be fully centered just by a little lift on the body of the compass. And then you lock it in with a few little button pushes, and there you have it. Read the azimuth, read the inclination, easy peasy. So let's talk for a moment about the nightmare of trying to determine trend and plunge of really steeply plunging linear structures. I'm going to use a prop in this case, this pole. And the nightmare is that for really steeply plunging linear features, you have to try to determine what the projection of the tip of that linear feature is in a horizontal plane. And it's so difficult. You can be off by tens and tens of degrees. But here's the deal with the axis. That is, you simply place the edge of the axis on the linear feature, and then you rotate the body of the compass in the way that we've done before, and level it, lock it in, and there it is. And you have a paired set of values, for the azimuth, in this case it's 275, and the plunge, which happens to be 87 degrees. Now, how are you going to measure that 87 degree, 265 reading, in a way that's going to be accurate? In this case, the multi-axis nature of the axis allows you to take care of it.